So we are working on Chapter 8b, Practice Problems. Question A, NVIDIA company just announced a future investment project with the following cash flows. And we're given the cash flows right here. And we're asked if the discount rate is 8%, what is the present value of these cash flows? All right, so I'm just going to go ahead and make a little table for my own benefit. All right, so I just went ahead and created a cash flow table just to help myself out a little bit. So what we have here is the time of each cash flow, the size or magnitude of the cash flow, and what I'm going to be solving for in this column is the present value for that cash flow. So what I'm going to do is solve for this value at time is equal to 0, and this value at time is equal to 0, and that value at time is equal to 0. I'm going to put all of these values times equal to 0 over here. And then what we're going to end up doing is summing all of those up at the bottom. So this is going to be the present value of total cash flows. I might just go ahead and put the equation that we're working with right over here. I'll go ahead and put R in this cell up here, that way it'll be easy to include within our cash flow calculations. All right, and the present value of 0 is 0. That's easy. The present value of $12.50 at year 1. So we're going to discount this back 1 year. So we'll take that value and we'll divide by 1 plus our rate to the number of years. And because I have Excel, I can go ahead and make this a formula that I can copy down. I'll still go ahead and verbally let you guys know what I was doing. So in this cell, we have this $830 value coming in at year 2. So discounted back 2 years to be at time is equal to 0, the present value, and we're using that same rate, 8%. And then I did the exact same thing with this $600 value. I discounted it back 3 years at 8%. And then for this $300 cash flow, I discounted it back 4 years at 8%. And now all we have to do is just sum up all these cash flows. And just kind of reviewing this formula right here, this symbol right here, that's a summation symbol. So it's just adding all the cash flows up, and that's going to give our total present value. So if we take the sum of all these, then we get $2,565.81. Hopefully you guys can follow that. This is not a problem that you need Excel for. You just take each individual cash flow, find the present value of those cash flows. So each cash flow, discount back to time at 0, and then you just sum all those up. All right, question B. An investment program promises to pay you X amount of dollars per year for 5 years, starting 1 year from now, in return for your deposit today of $8,000. What would X be if the interest rate for this project is 6%? Okay, so what we have here is a constant cash flow type problem, or otherwise known as an annuity. We know that because of the wording. It says it's going to give us a certain amount of money every single year for 5 years. And so in order to solve this, we're just going to go ahead and take our regular present value formula of an annuity. So I'll go ahead and put that right here. And with the given information, we're given the number of years, we're given the rate, and we're given our present value. So this is the deposit you put in today. And we're asked to solve for this cash flow right here. I'm going to start by just writing out what we know. All right, and if we rewrite this equation, we could just do the present value total, it was $8,000, times R, divided by this whole numerator, because numerator, when you put onto the other side of the equation, is going to become the denominator, and then that will be equal to our cash flow. So that's the equation that I'm going to go ahead and type in here. So our cash flow is going to be equal to present value times our rate, divided by 1 minus 1 plus R to the negative years. Again, this value right here is just rearranging this equation to look like this in order to solve for the value of each cash flow. All right, moving on to question C. Metro Investor requires all her investments to grow at a rate of at least 7% per year. She is now offered a contract that will produce the cash flows shown below, in return for a payment of $5,000 today. Assume there's no possibility of bankruptcy. Should she make this investment? All right, so I don't know what this event category is, so I'm just going to go ahead and clear that and move this over, because this is going to be a very similar question to what we did on question A. We're going to figure out the present value of these cash flows, and then I'm going to go ahead and solve for them. So we were told our rate is equal to 7%, and what we're going to do once we have our total present value of all these cash flows, we're going to see if that's higher or lower than this $5,000. If it's lower, then we don't want to make this investment. If it's higher, then according to Metro Investor's standards, this is a good investment for her. All right, so just the regular present value formula. Take the cash flow that you're getting, divide it by 1 plus our rate, and you put it to the power of years. Then I'm going to go ahead and make this copyable. I'm going to copy this formula down. Again, I did the exact same thing for this cash flow and this cash flow that I did for the first cash flow. Took it, I divided it by 1 plus our rate to the power of years. Again, same thing with the next one. And to figure out the present value of the total cash flows, all we have to do is sum up the present value of the cash flows. All right, and we find that the present value of total cash flows is higher than her initial $5,000 investment. So this is definitely a good project for Metro Investor to invest in, considering there's no possibility of bankruptcy. So our answer is going to be yes. All right, question D. Tesla Incorporated buys an auto assembling machine for $520,000. On the same day, so the exact same time that they buy this machine, end of year 0, the firm leases the machine to Toyota Incorporated for 5 years. Via a 5-year uniform payment annuity due contract with 9% interest. Payments are made annually. What is the amount of the uniform payment? All right, so for this problem, we're told right here that it's annuity due contract. So I'm going to go ahead and copy down our annuity due formula. And what we have to solve for is the uniform payment. So we're solving for this cash flow right here. We're given that our present value is 520. We're given that our rate is 9%. We're given that the number of years for this contract is 5. All right, and then we have to solve for this cash flow. So what we can do to further understand how we're going to solve for this cash flow right here is just rewrite this equation in order to solve for the cash flow. So I'll go ahead and write the cash flow is equal to present value, and that's going to be our numerator. And then present value is going to be divided by this whole thing. So say divide by So in this cell right here, I rewrote this equation in order to solve for the cash flow. Again, this looks like a lot of math. It's very hard to kind of demonstrate this via Excel in a way that might be easier to process. So I encourage you to maybe just write this out on a piece of paper. Hopefully it makes sense. It really is just present value divided by this entire quantity. All right, and we have everything we need, so we'll go ahead and solve this problem. Our cash flow is equal to our present value divided by 1 plus 1 minus 1 plus r to the negative n minus 1 divided by r. So yeah, there are a lot of parentheses, there are a lot of ones. So hopefully you're able to understand where everything's coming from here. We hit enter, and I got a negative number, so we know that's incorrect. Let's go figure out what I did wrong. All right, and in the formula test bar up here, I did not put it to the negative n minus 1, and that is a very important step. So when I correct that, we get the correct value here. So in exchange for leasing this $500,000 plus machine to Toyota, Toyota is going to pay Tesla every single year at the beginning of the year $120,000. All right, question E. The present value of the following cash flow stream is $10,000. When discounted at 8% annually, what is the value of the missing cash flow? Again, I don't know why we have this event column, so I'm just going to delete it. All right, so I've set up a cash flow table here that looks very similar to the ones we were using earlier. I'm just going to go ahead and figure out the present value of the cash flows that we do know. All right, so let's go ahead and see what we have. We'll take $3,000 and we'll discount that back using our 8%. Here. All right, now we'll go ahead and copy that formula down. So what I'm going to do to figure out this problem is I'm going to sum up all these present values that we have so far and figure out how far off we are from that $10,000 present value. So this is our PV tote of the known cash flows. So we're not too far off from $10,000. The present value of our missing cash flow is going to be $10,000 that we know all of it has to add up to, minus the present value of the cash flows that we do know. Okay, so present value of the missing cash flow is $1,000, but this is not our solution. We have to figure out what the actual cash flow is. This is just the present value of that cash flow. So we need to go ahead and solve for the missing cash flow by taking the present value and bringing it forward 2 years. We're going to take our present value of that cash flow, we're going to multiply it by 1 plus our rate. We're going to put it to the power of 2, right? And our missing cash flow is 1,308.9 cents. And we'll move on to our last question. Question F. A project has these cash flows. Present value total is $1,500. Cash flow 1 is $800 at time is equal to 1, and cash flow 2 is $900 at time is equal to 3. Write an algebraic equation used as a start point for finding the R of this project. So this problem is great. There's not a whole lot to it. We don't actually have to solve anything. We just have to set it up. So we'll copy the equation that we're going to use for this right down here. And this is just the present value total equation. If we just have an information that we know the present value total is 1,500, and we're going to set that equal to cash flow 1, which is $800. We'll divide cash flow 1 by 1 plus R, which we don't know, to the power of time, which is 1 for cash flow 1. And then because present value total is a summation of all the cash flows, we're going to add that second cash flow to this side of the equation. So we're going to add 900 divided by 1 plus R to the time period that this cash flow happens, which is 3 years in the future. All right, and to solve for R, you would have to solve this algebraic equation.